Hey everybody, Mr. Regan here, and hopefully we have a solid foundation about what our variables are within our experiment and how those variables are going to help us figure out and answer our investigating question that if we have the same force exerted on two objects, how would that effect be different, okay? And within our experiment that we looked at earlier, we have our two different balls, our golf ball and our ping pong ball. We have our spring that we're going to be using. We have our meter stick and our timer that's going to help us measure stuff. And we're going to hopefully get some good results here to help us figure out what's going on in space. And we're going to use this experiment to represent what's going on. So within our experiment, our independent variable is what we are going to be changing, what we are going to be testing. And in this case, it's going to be, well, how much weight these objects have. We have our golf ball, we have our ping pong ball, and if you know anything about these two objects, you'll know that they have different weights. And there we go. That is what we're going to be testing to see, well, if we have these different weights, what's going to happen when we apply that same force? So we're going to apply the same force. That's going to be one of our controls. We're going to give both of the balls about a 2 on our force spring here, and we're going to observe a change, hopefully a change in their velocity. Now, right now, our objects have a velocity of 0, and what we're going to do is we're going to use our spring at force number 2, and we're going to hit both of them, and we're going to time and measure that distance and the time it travels to get to the box. Now, why do we take these measurements, okay? Sometimes our observations can be flawed, or we cannot be very precise in our observations, so we take measurements to be accurate and precise as to what is occurring. So we could say that our objects are moving faster or slower than each other, but if we have data and measurements to support that, we'll have stronger conclusions that we're able to draw, stronger conclusions that we can use with that measurement and those evidence to make sure that what's happening here could obviously represent what's going on with our pod in space. So how do we measure velocity? Well, we know that we have a few equations that we use that can help us measure how fast or the speed of an object. So velocity is speed in a specific direction. So speed plus direction. So I could measure its speed traveling towards the box. But that's not really going to give us any measurements because, well, speed is something we have to measure as well. So the speed of an object is the distance it travels divided by the amount of time it takes. So in our situation here, we're going to have our objects travel a specific distance, and we're going to measure how long it takes them to travel that distance. And then we're going to calculate its overall velocity. So to do that, we would take the distance they traveled divided by the time it takes to travel. Now, we're going to be running this experiment here shortly, but before we get into that, let's practice how we would calculate the velocity of an object, okay? So in this case, we were going to take the speed, which is its distance divided by time, and then we're going to have its speed within a specific direction. So we have a few examples here in our velocity calculation questions that give you the distance of some random things. It could be the distance that a car is traveling at a specific speed. It could be the distance that a person is walking at a specific speed. And it could also be the direction maybe some smaller object is traveling at a specific speed. So what you're going to do is you're going to practice calculating velocity using the equations we have over here to help you figure out velocity. Well, we know velocity is the speed of an object in a specific direction, and we know speed is distance divided by time. So let's say I have a person who's traveling, let's say 20 feet, and it took them, 10 seconds. If I was going to set up my equation, I would do 10 feet divided by 20 seconds, and obviously I would have 2 feet per second, okay? Now, that would be my speed, and if we wanted to make it velocity, we would add a specific direction. So maybe they're moving 2 feet per second towards the school, or 2 feet per second north. And that would help us to get our velocity or accurate measurements as to what the velocity of that person is. So before we get into our lab and calculating the velocity of our two objects, let's do a quick practice. Go into that velocity calculation question table, calculate the velocity of those three examples just to make sure you have a solid foundation, and then reach out to me, obviously, if you need any help. Good luck.